In this video, we will continue on affective computing and we will see how to detect affective states from facial expressions. So, again the papers which we listed in last slide, these are the slides will be used for this particular for the slide. Go and check these papers to understand even more detail. So, the one good way or the one the baseline method or the method you have to compare detecting emotion is human observations. Basically you get trained on how to detect emotions and there are ways to do that, and it is better always you have multiple observers instead of you alone detecting students emotions, have multiple people to observe. So, we talked about this in in a kappa score prediction that there are two ways detecting students emotions, such as two ways detecting students frustrated or not, and they are getting an interrelated. So, if you are doing the human observation, you have to establish the inter-rater reliability using kappa score, Kogan's kappa. The other way is self-reporting. The person is self-reporting their emotions by observing their own facial expressions. How to do that we will see, or you can have some questionnaire coming into system. How are you feeling now? I am feeling bored or confused. They can select their own options. That is the way you can think of. So, in order to detect facial expressions by using automatically, Paul Ekman's research suggested that there are action units in your face. There are a lot of action units in your face, such as inner brow rise, chin, lips rising, nose wrinkle, all these things are action units. So, the Paul Ekman listed down all these action units in a facial action coding system, FACS. Let us see that in detail. If you check that link in a facial action coding system, it is a Wikipedia link, you can go and check it, and you will see there are there are 28 EAU main codes, and based on head movements there are many codes, and based on eye movements there are more codes, and there are more codes in visibility codes. So, what is this codes? For example, inner brow rise or outer brow rise, and this each and every action units in your facial muscle is actually mapped. So, to know more about this this 28 codes, go to the link about facial action coding system, a visual guidebook, a blog by the company called iMotions, which is pioneer in in collecting data from different sensors like eye tracker, facial expressions, GSR, EEG. They collect all the data and they sync it, they provide complete picture. So, that is one thing. So, let us see. Inner brow rise is all GIFs explain what is inner brow rise and what is outer brow rise. So, you get trained on these codings. Once you have getting trained of these codings, you can now you can say happiness or joy is 6 plus 12, that is cheek raiser plus lip corner puller, which if you have both then it is a kind of a happiness, you can say it is happiness, and sadness is it is kind of this kind of that. So, you can combine this action units and that can produce you emotions. First step is identifying what are the action units, and you get yourself trained. These three combinations is sad, this thing combination is happiness or something like that. Then that is exactly your happiness, sad, surprise, fear, anger, disgust and contempt. So, this is 7th one, contempt is recently added. So, there are 6 basic emotions which Paul Ekman suggested in 1960s paper. So, this is the Paul Ekman's work, and using this you can actually detect the human sex emotions. Let us go back to the slide. So, some of the action units we thought about it. So, we check the blog again, and how do we combine, how to do it automatically is we will see. So, there are more examples that AU1, AU2 with the figures and pictures, you can check those details here, and all the blog which I showed in iMotions is really helpful to understand that. So, what is affect? It is a combination of action units like 6 basic emotions, And how to detect this affective states? Let us look at another blog by iMotions. So, what is a facial expression? So, why it is happening, the details are given here. You can go more detail, and the basic emotion is what detected here, and there are a lot of details on why this expression is happening, why there are 24 action units, the details are given here. So, for example, this 1, 3, the 3 action units indicate the person is kind of happy or surprised or something like that. So, or so these are the expressions, combination of expressions indicates the person's emotions. So, how do we detect that automatically? By using web camera or something like that. So, what happens really is in a web camera we capture the video, actually video is 25 frames per second, 25 pictures in a second. So, in a second you will have a 25 frames, the frames time is there. What happens here, the first step is using the AI, we detect the face, only the face of the human. So, in the whole picture the face is detected. After detecting face detection is easier compared to detecting the macro expressions, that is AUs, because a lot of work has been done in this field of detecting face or detecting facial expressions or facial detections nowadays. So, face detection is easy. After detecting face, the part comes here is like detecting the action units, like marking them, which is upper eyebrow or what is the cheek, what is the lips, nose, you marking them and classifying them as action units, AU1 or AU2 is doing. So, to do that they have million faces database and they have trained like all the face has been labeled properly and they trained it. So, they compare with that and they classify the given image is smiling or not, or lip corner pulling or not, those kind of classification is happening. Once you classify it, if you identify the AUs, that's by a company called Affective is doing it. The iMotions is actually a company which integrates product from different companies. This particular model we are talking is by a company called Affective. And after you collect this facial expressions, after you have this action units, again give those to a new classifier. That classifier will help you to detect the emotions. That is the whole idea of how to use it. Let us see that again in briefly. So, what happens here is your facial expression in a video is captured. After that it just 25 frames per second, and from each frame it detects the face. After detecting face, it detects the action units, that is the action unit detected by comparing that particular area with the trained database, and from that information it classifies the action unit is happening or not. There are classifiers are trained to detect action units like a simple machine learning classifier. Most of them it is support vector machine or the advanced neural networks ones. So, what happens here is from the action units we have to predict the affective states. So, what actually happens is for example, the data will be like this. Say suppose the student ID, action unit 1, action unit 2, AU3 and say AU29 or 30, or then timestamp. So, what happens is basically the action unit is not giving a binary classification. Instead of a binary classification, they are giving the probability values, saying that what probability that this action unit might be occurring. So, say 0.8 some values, this is say 0.2 or something. So, now you have a lot of values coming out, AU1 is happening, might be AU1 also AU7 or AU8, we do not know. So, again they trained a big classifier and to combine these action units to detect and give the affective states, that is emotions, boredom, confusion or or anger, fear kind of emotions. So, that is what is actually happening in the back end while detecting the students facial expressions. So, iMotions is commercial company, and the cost in India, its cost is really high. It's could be around 5,000 to 6,000 euros. There are some open source things available from Carnegie Mellon University. It's called OpenPOS. So from CMU, OpenPOS is another library available in GitHub for free to use it. But CMU is not give you the emotions detection accurately, or final emotions maybe. But what you have to do is check those open posture, and they detect not just facial expressions, also the posture of your body. And using that data, you might have to do the labeling by human observation or self reporting. Then you have to train your own classifier. We will see how to do that now. So before going into detail about the papers on facial expressions, how the interaction between facial expression has happened, can you list down the drawbacks in facial analysis emotion recognition system, like the one we saw in a previous slide, like iMotions, where they use students' facial expressions from the video, and they classify the face and classify the action units, and they detect emotions. Can you list down the drawback? Yeah, please list down the drawback, then resume the video to continue. So the drawback, the key is training database. You need lot of training database for this, and which means millions of data has been labeled to create data and to classify action units correctly and provide accurate emotions. And in a real places, like noisy classrooms, it will not work. A student has to interact alone, or if two students are working, you have to mark it one, and you have to show only one student's facial expression, detect emotions, and do that. And facial rotations are not captured by Affectiva, but Affectex does that. The movement of a head, yaw, roll, pitch. That data has to be if I just change my face direction, I just show my different emotion, what happens? System may not able to detect that. And artificial emotions, that is simulated emotions, is used to train these kind of classifiers. How they got labeled? Because they asked the participants to simulate the emotions, like you show happiness, you show anger, then they try to code, and that is the labeling is happening. So that may not be correct to detect the real natural emotions. And the most important problem in iMotions or the facial detection system software is they detect only basic emotions, because Paul Ekman studied about basic emotions and he listed on all the action units, and which kind of action is combined together will give the basic emotions. But when we are interacting with the learning environment, anger, fear, that's not going to happen, anger. Instead, there will be more of learner centric emotions, as I was telling. Boredom, confusion, frustrated, engaged, delight, those kind of things. So in order to detect those emotions, we cannot use iMotions kind of software to detect emotions automatically. Okay. So I will see couple of methods how they do it. One is human observation. In this human observation, there will be coders, trained coders. And there is a tool called BROMP. It's created by Professor Ryan Baker and Jacqueline and Rodrigo, Professor Rodrigo and Jacqueline Ocklenberg. So it's a Baker-Rodrigo observation method protocol, and the BROMP tool is simple tool. It's not it's not automatic system. Don't get that. It's automatic system to detect emotions. It's a simple mobile app. It's the app. What happens is, if you are observing say 10 students in the class, so there are student 1 and student 2 and student 3 and say S3, S4, S1. Consider you are observing 4 students in the class, you are the human observer. This, how do you observe basically? So we want to observe. So first you will observe in a round robin method. First you will observe student 1 for 20 seconds, say 10:00 to 20. You observe the student 1 and this is student 1 and you note down the emotions, maybe bored. Then you go to S2, then you note down, you observe for 20 seconds, then you note down the student is neutral, there is no emotions, he is actually focusing, engaged. Then 40 to 60, you might observe student 3 may be confused. Then student 4 again it is 10:60, then it will be 10:01 00 to 10:01 20 seconds, and you will be observing the student's emotion as say S4 may be confused, bored or frustrated. So, what is happening here is as a human observer you are actually having a paper, pen and paper, and S1 you are looking at them and making sure there is a time, you might be looking at the time, then you note it down. So, instead of that the prompt protocol tool actually helps you to do that. You just have to, there will be like a student's name will be there, you just have to student name, you click the student name and the time is automatically recorded from the your computer, and there will be like 6 emotions, you have to click it. So, your time of recording is saved. That is the simple observation method protocol, the tool which tells how to do it. But here they observe the humans, not just a facial expression, the holistic approach, the students interaction with the system, the gesture, the screen, what are they working on, are they talking to a sphere, all this information is observed, then this emotion is noted down. Why 20 seconds? That is a very good question. They want to observe at least 20 seconds and make emotions. And if you talk to a psychologist working in a HSS department, or they say emotion won't last for 20 seconds. There is no possibility that you get confused for 20 seconds. The emotion surprise comes max, it stores for 3 seconds, 2 seconds, that is it. But if you want to go to 2 seconds or 3 seconds, such a fine grained kind of emotions, it is not possible by the human observers to observe those every time, unless you are observing recording the students action in a video, then observing coding every second by second. The problem is 1 hour video to code it might take more than 2 or 3 days. Such a huge data, such a fine grained data you will be end up with if you observe the videos for every second. So, 20 seconds is the logical approach they found out. It may not be true, you might have the new ones. Okay. So, prompt is a protocol, it is a kind of app which helps you to map it. If you are happy, if you have your own notebook and you have your own timing schema to do that, it is good. You always go S1, S2 in the round robin method, there is no need to record it. And you have a timer above it, every 20 seconds you press the timer and you mark it, then no need to detailed timer is needed, just you have to say bored, confused, neutral, then you are good, there is no need of the app or tool, okay, that is it. So, basically what happens is it's a human observation, the trained coders, the coders got trained in the sense, so one coder, a couple of coders code the students emotions and they make sure that interdata relativity is high, the covariance kappa is 0.8, then they move on to the next. The observers got trained and they can go independently start collecting data from the students. So, the observed affective states can be different, whatever emotion you want to do. So, now we can use the learner centric emotions like boredom, frustration, engaged, concentration, confusion, all these things. Then you also can not just the emotion, you can also another table saying that the behavior, are they off task or on task. It is very easy to detect, this is one of the easiest to detect, are they talking about the task they are doing or just talking about something topic and still engaged, that is the whole thing you can also observe. And after you observe this data, right, which means student 1 you observe at 10 minutes 20 seconds, again you will be observing the student 1 at 22 10:01, 40. So, you will observe a student at every every 80 seconds. Once you have a data like that, then they create lot of features from the log data. Okay. So, what happens here is again you go back to your features creations and using the machine learning classifier. For example, so what happens is the timestamp. So, that is a timestamp and student ID S1. From the student's log data, that is the interaction system, you compute feature 1, feature 2, so 100 features. Then there is a label. Label is the emotion you detected, that is bored. Maybe this is student ID S1, S2. If you detect, if you create that, so which means you need to have at least thousands of observation happened in a real classroom. Then you will have this table. After having this table, what happens is you use a machine learning classifiers to predict the label from the features, and that's it. That's the whole idea. And they create different ML models for different emotions. You can train only for boredom, you can train only for confusion. So, different ML algorithm might give a better approach. So, use the one which gives better approach and use them. That is the whole idea of creating automatic emotion detection using log data. Here the labeled information is from the human observation. Okay. So, I said that in a tele you have to come up with a lot of features to detect emotions. Now, pause this video and list down what are the 5 features you think is needed to detect emotion from a tele. We know what are the interactions people do with tele, that they interact with a problem map, or they go create concept map, they go to simulator. And imagine the tele we discussed in our class, metal, and try to think of 5 emotions. If you think of any technology enhanced learning environment, anything you have used, and think of what are the 5 features you think it's important to detect emotions. So, the 5 is not a number, just giving you the idea to think about the features to extract from the log file. Pause this video, write down the answer. After writing it down, resume to continue. So, there are a lot of features used in the in the emotion detection. Atom frequency, XMX clicks, how many clicks has been happened, what are the interactions happened, what are students off screen time, on time, off screen time, are they looking at it or not, if you have a facial expressions camera like webcam, or are they spending on time on this particular task, and are they spending time on this particular transactions from this page to this page. If you have eye gaze data, you can talk about fixations, or if you are watching video, are they playing, passing time, and if they are posting video upward, downward. So, whatever features we thought about in our previous class, list down all those features, okay, and make more number of features. For example, how many clicks in last 3 minutes, how many clicks in last 5 minutes, how many thing in last 10 minutes. So, the frequency for last few instances, all the time they spent, how much time spent on this particular video in last 1 minute, how much time they spent on reading the resource for last 5 minutes. Such a such a features we expand it more. This features generation comes from domain expertise. Professor Rand Baker, when he was telling that this knowledge he gained from creating detectors for multiple systems over a decade, and is able to create the feature engineering and features come up with. So, it is not an easy task, you won't get it all the features in the first time, you won't get a better classifier in 1 year in the first time. So, it start with that and collect more features, create more features, or read papers published by Professor Rand Baker on detecting emotions in the different systems. Then you get the idea how to create features. Okay. So, after you create features, human observation is independent data, features is the X is the features, and let's take a simple linear regression kind of approach, W1 x1, W2 x2, and W3 X3 kind of weight is, which is what you are trying to estimate from the training data. It is kind of a matrix. Once you have matrix, you can apply to multiple ML methods. So, check this paper, it is an interesting paper, check it, or if you want to more detail on detecting only detecting only how to detect frustration from a log data, check this thesis. I worked on this to detect students frustration from log data, and here also I used human observations a lot. So, let us move on to other approach. Here Professor Professor Sidney De Mello tried to understand the dynamics of affective states from the theoretical analysis of these emotions. The emotions is not it is from the computer science department or something, it is an interdisciplinary program, right. So, this affective states is from psychology. So, from the theoretical knowledge of affective states, this is what is kind of coming up. It's like there is a flow. Flow kind of leads to confusion if there is some emphasis detected, something is stopped or some emphasis detected, and if the goal so if the confusion leads and your goals are blocked, then you might get a frustration, and if the frustration continues, you will get boredom and you might drop. And if suppose if the confusion it gets resolved, there is some issue, you are reading it, you are some stuck in it, you are not understanding, you might get confusion. If that stuck part, what is stopped you, which is got resolved, then you might go back to flow. Flow is like engaged. Again you continue engaged in the particular learning content. This is the dynamics of affective states from the theoretical approach. Let us see is it holding true in data we collect and you predict. So, what Sidney De Mello and his colleagues did is this, they used a system called AutoTutor. It is a voice based interaction system where you have to speak to the system, and based on what you speak, the conversational agent will answer your questions. Here you have to learn topics like hardware, internet, OS or something like that. For example, the system asks you the question, when you turn on this computer, how is the operating system first activated and loaded into RAM. So, it is actually a question, the agent actually a text to speech converter, he speaks. Then a student types the answer instead of speaking, because voice recognition is not so great at that time when this AutoTutor is created. So, when a computer is turned on, a file is automatically booted up, then it is asking for more information like hey, what happens. So, then if you stuck, it might provide a hint, all these things happening in this AutoTutor. So, imagine a student is working on this kind of environment like AutoTutor, and what you do is you record students facial expressions and posture, also you record the interaction screencast, screen capture, okay, you observe both. Okay. So, after observing both, what you do is you ask the students to self report. What I mean is so after student is interacted with the system, show two screens to the system, two screens. One is screen capture, one is students facial expressions, the webcam image. This is from webcam. Now, if a student interacted with the system for say 30 minutes, you pick 20 intervals of time, or 30 minutes if you want to say I want to detect 20 instances of emotions. So, at every 1.5 minute or every 90 seconds you pause the video and you show 5 seconds of screen capture and the facial expressions. Ask the students to self report, there will be a menu bar, ask the students to report their emotion like a frustrated, they just select the option. You show what was students doing, the contextual information, also the facial expression to the student, and ask them to report their own emotions at the particular time, so self report. You can have a human observation also to check if this is happening or not, or you can ask a peer to report the peer's emotions, then you can compare whether two people are reporting it correctly or not. So, randomly pick 20 times and detect emotions, or that emotions can be used as a label, and you can use data from eye motions action units. I was telling that from eye motions you can detect the action units. Now using the action units from the eye motions and the label data from the self reporting, you create a machine learning classifier. Again the classifier will be using 20 seconds interval, or you can use the log data at 20 seconds interval also, because the action units at 20 seconds interval will be used to detect the emotion, that is all 20 seconds interval. So, how do you combine the action units to 20 seconds? Get the dominant action units there and just do it, or read the paper to know the exact approach. So, from analyzing that, what actually happened is this table has come out. Here the double star indicates there is a significant flow. There is a flow from there is a transition from engagement to confusion, there is a transition from confusion to engagement, and there is a transition from confusion to frustration. These three are significant, and they did a one sample t-test instead of to check whether it is reliable or not, and the significance is good, and the number of student sample used also given here. Similarly, boredom to frustration also significant transition is happening, other things are not significantly transition happening. They repeated the study again with a new system, and again they found out except all of them except frustration to flow is also happening, and frustration to boredom also is happening within the students. Now in this report they randomly selected 20 pre-selected points, also 3 random points has been given to students to self report and 30 participants. And now with these two data from the empirical study, we are going to see whether we can plot the theoretical model of affective dynamics. So, that is what they did here. So, this is the dynamics of affective states obtained from this is the dynamic of the states obtained from the self reporting and predicting students emotions based on the action units. Let us see. So, here equilibrium, the flow is actually there is a significant transition in both, they can go to confusion or they might come back to engagement, also significant transition by both and significant transition between both. There might be a transition from boredom to confusion or boredom to engagement, but it is not significant, that is what this indication says. That this particular picture says that wherever the significant transition observed from all the students is shown here, but it is not that there will not be any transition from boredom to confusion, there might be a transition. So, this is how the facial expressions are used to detect learner centric emotions, that is by human observation and collect log data and predict it, or you can ask the students to self report at that particular 20 or 30 instances of the time they are interacting with the system and predict the students emotions. And that is the two methods we saw, and this affective states dynamics gives us a more important information that if the student is in confusion state, you need to understand why that student went to confusion, what actually impasse is created. If we solve that, he will go back to engagement mode, if otherwise he will get stuck in the frustration mode. So, yes, so we have to think of what kind of feedback can be given at this particular moment. So, that is why this particular model is very important. So, we saw human observations and the self reporting has been used to detect emotions. What are the challenges in human observation self reporting? Please think about the challenges, write down your answer, then resume to continue. Human observation and self reporting is time consuming. Firstly, if you do human observation, I said that it takes several hours to code 5 minutes of video, and self reporting itself a problem in the sense students are self reporting, it may not be true. So, you have to confirm whether the self reporting is correct or wrong. And so, if human observation is happening once in 20 seconds and self reporting also happens in the interval, accuracy of this particular system is not so great. In fact, the kappa score of the detectors which I talked about, the plus 2 detectors, is really bad, 0.2 or 0.3. If we know what is a kappa score, what that means. So, accuracy is not really great, it is really bad, and we can't go and make a decision by using the report come from this indicators or detectors. So, that is the issue. And when you do the human observation, the main thing is please do the inter-rater or inter-observable reliability, that is Cohen's kappa, and make sure you get more than 0.8, and that is not easy to train the human observation. That needs more time and more training for the human observers. That is the idea. So, in this slide we saw what is affective computing and what are basic and learner centric emotions, and how to detect those emotions from the basic emotions from iMotions kind of webcam based systems, automatic systems or open posture, and learner centric emotions can be detected from log data or other data if you have a human observation or self reporting as the label data. Thank you.